Show. My name is Layla The Great. Today, I have a lot of things to show you from my magical bag of tricks. I also have a few surprises hidden under the table. Look at this! This looks like an ordinary rock, doesn't it? But it can do something no other kind of rock can do. Watch. When I put a few steel nails close to the stone, presto! Lots of nails hang on to the rock. This kind of rock is called a lodestone. See this picture I drew? A long time ago, some sailors thought there were mountains made of lodestone in the middle of the ocean. The sailors were afraid the lodestone would pull all the nails out of their ships, and the ships would fall apart and sink. Of course, no mountains like that ever really existed. Do you know why nails cling to a lodestone? A lodestone is a natural magnet. That's why. And a magnet is an object that attracts certain metals, such as iron, steel, and nickel. Here, in my bag of tricks, I have lots of different magnets. Magnets come in all different shapes and sizes. These long, thin ones are bar magnets. The round ones are called ring magnets, and the other ones are horseshoe magnets. Now, here's a good trick. Why do you think all these metal pieces are sticking to my shirt? See here? I have a bar magnet hidden inside my shirt pocket. A magnet has an attracting power called magnetic force. As you can see, magnetic force works through cloth. Suppose this white metal strip were a refrigerator door. For my next trick, I can make this piece of blue paper stick to it. And I don't mean with glue either. There! I held the paper to the metal with this flower. A magnet hidden behind the flower clings to the metal. So you see, magnetic force works through paper too. Now, look at this glass of water. See the paper clips at the bottom? I can get them all out of the water without getting my hand wet. Can you guess how? The magnet pulls the paper clips over to the side of the glass. Then, I slide the magnet up the glass. And the magnet lifts the paper clips out of the water. Neat, huh? As you can see from this trick, magnetic force works through glass, too. Here's a great trick. Look at this metal grate. It came from the end of my driveway when we had the driveway fixed. It kept leaves and trash from going down the drain. Suppose somebody dropped a bunch of keys through the grate. My hand's too big to fit through the grate. Can you think of a way to get the keys out without removing the grate? A magnet does the trick. Tie a string on a magnet, and then you can lower the magnet through the grate. Presto! The key ring sticks to the magnet. When you pull up the string, magnetic force holds the key ring to the magnet. Look at this bar magnet carefully. If a magnet is so powerful, why can't we see the magnetic force? Magnetic force is invisible. That's why. The area with magnetic force around the magnet is called a magnetic field. Now, here's an excellent trick. I can show you where the magnetic field is, and this jar holds the secret. The jar is full of iron filings, which are little tiny bits of iron. First, I need to get out my light box. It's a flat case with some long, thin light bulbs inside. Now, I have the lights turned on. Here, I put a bar magnet on the box. Next, I lay a colored plastic sheet over the magnet. For my magic jar, I sprinkle some filings on the plastic all around the magnet. The light makes it easy to see the filings. Voila! The filings become arranged by the magnetic field in a pattern around the magnet. They show the pattern of the magnetic field. See how the filings line up at each end of the magnet? The magnetic field is strongest at the ends of the magnet. The two ends are called the poles. I'm pointing to the north pole of the magnet. The other end is the south pole, where you can see the letter S. Before I show you my next trick, let me tell you this. The Earth acts as though it has a huge bar magnet inside it. I've drawn these red, swooping lines to indicate where Earth's magnetic field is. The Earth has a magnetic pole in the north and a magnetic pole in the south. Earth's magnetic field is strongest at the poles, just like the magnetic field around a bar magnet. Now here's an amazing thing. This is a compass. When I hold the compass flat, watch what happens. See, the red end of this compass needle will always point north. Here's why. The compass needle is a small magnet. The red end is attracted to Earth's magnetic pole in the north. Since the compass shows direction, you can use it to help find your way. Let's get back to a regular bar magnet. You can see on this magnet that the north pole, which is at the red end, is marked with the letter N. The south pole, on the white half, is marked with an S. If you put a north pole and a south pole close together, whammo! They attract each other. The rule is this: unlike poles attract each other. But if you put a north pole and a north pole close together, they repel each other. That means they push each other away. The rule here is, like poles repel each other. For another trick, I can show you repelling in action. Here are the two bar magnets under a pink plastic sheet on the light box. There are very few iron filings in the space between the two north poles in the center. The poles are repelling each other. But look, when you put a north pole and a south pole close together, they attract each other. The iron filings show a strong magnetic field between the unlike poles. This trick will give you something to think about. Here, I have two cups. Watch what happens when I put the red one inside the blue one. Abracadabra! The red cup floats up inside the blue one. When I push the top cup down, it stays down only as long as I hold it down. But as soon as I let go, the top cup pops up again. Can anybody come up here and tell me why? Okay, step right up, Carmen.
Are you using magnets?
Yes, you're right. Let me show you exactly how I use the magnets in this trick. See? I taped a magnet to each cup. When I put one cup inside the other, the like poles of the two magnets repel each other. That's why the top cup floats above the other one. Carmen, you can help me with this trick too. See this wooden stick? First, I'll put this ring magnet on the stick. Now, you put the other ring magnet on the stick. That's right.
Wow, look at that. The top one won't go all the way down.
The top magnet floats above the other one because the magnets are repelling each other. Isn't that neat? For my next trick, I need another volunteer. Okay, Willie. First, I want you to examine an ordinary screwdriver. Is it magnetic?
No, it won't pick up any of these little round metal washers. So what's the trick?
Watch closely. I'll show you how to make a magnet. I rub a magnet down the screwdriver blade about 20 or 30 times. Presto, changeo. Notice that I always move the magnet in the same direction. Ta-da! Now, see how the screwdriver picks up the metal washers? Do you want to know how this works?
Yeah!
Okay, I have 2 pictures to show you. The steel screwdriver blade is made of tiny particles too small to see individually. These particles are like little magnets. Ordinarily, they all point in different directions, like this. After I rub the screwdriver blade with the magnet, most of the little particles line up and point in the same direction. This makes the blade a magnet. I can make a magnet in another way, too. This is an ordinary metal bolt. I have wrapped a wire around it. The bolt isn't a magnet yet. Now I have connected one end of the wire to a battery. When I connect the other end of the wire to the battery, electric current will flow through the wire. Ta-da! The current in the wire makes the bolt magnetic. This kind of magnet is called an electromagnet. The current produces a magnetic field which causes most of the particles in the bolt to line up in the same direction. For my last trick, I'm going to show you a magician's trick. As you see, the scarf is red and blue. Now watch. As I run my hand down the scarf, I can make it change colors. Hocus pocus! Now the scarf is yellow and green. This is a trick real magicians use. Abracadabra! Now I have changed the colors back to red and blue again. Do you believe this is really magic? The trick is actually in the scarf itself. See how the red is part of a trick pouch? It's red on one side and green on the other. The pouch turns inside out and the scarf appears to change colors magically. It's a neat trick. Just as there was actually no magic in the scarf trick, there's no magic in magnets either. When a magnet attracts pieces of metal, it's the natural force of magnetism in action. Still, you've seen magnets do amazing things. You've seen attracting and repelling, and you've seen how to make a magnet. And now you're going to see me disappear, because that's the end of my show.